So starting our first topic in optical instrument, this is a prism. Okay, you know what is a prism? A prism is a portion of transparent medium. It is an optical instrument that is used for performing the phenomenon, optical phenomenon. Its name is dispersion. Okay, so we have studied reflection first, reflection, then refraction, then total internal refraction, and this is fourth phenomenon called dispersion. Dispersion means splitting of light into its seven constituent color. Okay, after splitting it, it is notice informed. We have informed that the light is made up of the seven colors. Okay, so mainly the dispersion is a technique of splitting of light. So a prism is a portion of a transparent medium bounded by two plane surfaces inclined to each other at a suitable angle. So actually prism is a 3D device and it is looking like this. You see here it is a rectangular faces. First one rectangular face and this is the second one rectangular faces. Second face. Okay, three rectangular faces are there. One is at the bottom of the prism. It is looking like this. One is at the bottom of the prism. One, here it is two, this one is three, and the final one is four. So this is the bottom face. The yellow one face is the bottom face. So all total there are three rectangular faces. This one rectangle, the left side, the right one side is rectangle, and the below one side, the bottom side is rectangle, and these two faces are triangular. Okay. So when we see the prism from here, we are able to see only this one face. That's why in each of the diagram we are taking this face, rectangular, triangular face. This angle A is called angle of prism. Yes. This angle A is called angle of prism. Okay. So we have to take this one section during our studies. You have to consider this one section only. Clear? That's why we consider the prism as a triangle, but it is not triangle. Three rectangular faces are there, one, two, three, the bottom one and the two triangular faces. It's a solid geometry. The prism is portion of transparent medium by the two plane surfaces inclined to each other with a suitable angle. Yes, like this. See here the three rectangular faces. One is at the base, and the two rectangular faces are bending with some angle that is called angle of prism. Hmm. In the figure ABPQ and ACRP, check here ABPQ, AB and PQ is first phase, and ABRC, this is second phase. ACRP, the second phase are at the two refracting faces. These are called refracting faces because the light is incident here. This is called incident ray, and after the refraction and dispersion, the seven rays are coming from the another phase. Okay, and you will have a band of light. This is band of light is called spectrum. Got it? Hmm. Angle A between them is refracting angle or angle of prism. Yes, important. This angle is called refracting angle or angle of prism. Now see in which way your dispersions, your refraction from the prism takes place. The line AP, the line AP, where is AP? This is AP. Okay, the line AP where the two refracting faces are meet called refracting edge of the prism. Yes, check here the line AP by green color. So this line AP. Okay, so this is the first face, upper front one triangular part, and this is the back one triangular part, and this edge is called the refracting edge of the prism. A section of ABC of the prism made by a plane at right angles to refracting edge of prism is called the principal section of the prism. Yes, so you have to take one of the section. This one is the section ABC, the triangular section. Clear? Our whole now the coming optics is totally, we have to work on this section only. So refraction through a prism. A ray of light suffers two refractions passing through a prism. hence deviation through a certain angle from its original path. Now make a diagram in which way the refraction by a prism takes place. Okay. So here I have a ray. First, it is incident ray, that is incident at some point on the first face, refracting face of the prism, like some here. So this is L1. This is point is L. Okay. So first you have to made the normal, because we have to perform the refraction with respect to normal. So first it is the normal number 1. We have considered a normal here with the name N1. Draw the normal, students. Now this ray, incident ray, making some angle I1 from the normal. When the ray is coming from rarer to denser medium, it will bend towards the normal. Actually, the ray has to pass like this. This should be the original path of the light. Okay. But it bent towards the normal by making some angle of R1 and passes like this. Clear? So I1 is the angle of incidence and R1 is the refraction angle. And NO is the normal for the first surface. Clear? Mm. Now it incidented on the point M, and N2O is the normal on the second surface. This is the normal. The normal meet at, both the normals are meet at angle O. So give this angle at angle O. Clear or not clear? Okay. Remember, this angle equals to 90 degree. I'm talking about which angle? See it clearly. Normal to the surface. Yes, this angle equals to 90 degree. And this angle also equals to 90 degree. The normal angle. This is the surface and this one is the normal. So this angle equals to 90 degree. Clear or not clear? Hmm. So if you're talking about the quadrilateral A, L, O, and M point is here. Clear or not clear? You check this angle equals to 90 degree, because A, sorry, it should be P. No, no, fine. So this is normal with the surface. This is normal and this is surface. Again, this is normal and this is a surface. So this angle equals to 90. Means the sum of these two angle L plus angle M equal to 90 degree. So angle A plus angle O will also have a sum of 180 degree, because these both angles contribute a sum of 90 and 90 equal to 180. So by the property of quadrilateral, angle A plus angle O has to be how much beta? 180 degree. Got it? Okay. Now talking about refracted ray. Now check the refracted ray. Once again, check the refracted ray. This is incident ray. This is refracted ray inside. This making some angle R2. So first angle of refraction is R1 and inside this angle is equals to R2. Okay. Now this is a normal. Now with respect to normal, the emergent ray, as it is passing from denser to rarer, it will bends away from the normal. Yes. Its original path is like this. It bends away from the normal and making an angle I2. Somewhere it is called angle of emergence E. Okay. Angle of emergence E. And finally it is passed out. Clear? Now what is the direction of incident ray? Yeah, this is the direction of incident ray from L to Q. And what is the direction of emergent ray? Final emergent ray is the direction of this. So make it extend. This is the amount of deviation. Okay, where the rays has to go and where it has passed. So the angle between the predicted incidence direction and the emergence direction is called angle of deviation. This angle is called delta. Clear? So you have made the clear diagram of this and mention all the angles R1, R2, I1, I or E. Okay. In calculation, some of the places it has to be I and I2 angle as E. Clear? Okay, so yes, you have to draw. Okay, so starting the derivation part of refraction through a prism. In this derivation, we have to find the refractive index of the material of the prism, mu. Okay, so consider a triangular prism. Write the consideration. Consider a triangular prism. Let a ray of light PQ strikes on the face AB. This is the face AB of the prism and then refracted by the face AB towards the base of the prism. Yes, so this is called base of the prism. So after the refraction, this light ray is refracted like this, and after the end it is emergent at an angle E. This is called angle of emergence. Consider this one angle as R1, this is R2, this is angle of incidence I. Okay, this is incident ray, this is refracted ray, and this is emergent ray. Clear, students? Now this both the lines behave as a normal, the yellow one, the green one line, these lines are as a normal. So these are on the perpendicular on the surfaces AB and AC. Yes. Okay. And they intersecting at a point N. This is called angle of prism. Okay. And incident ray, if you extend the incident ray in the direction of incidence, it is looking like this. And this is the emergent ray. When you cross the incident ray and in refracted ray, emergent ray in previous direction, you will have this angle delta. This is called angle of deviation. Okay, we have to estimate the condition of minimum deviation when the light ray was deviated in a minimum way. Okay, what is the angle of value of delta? What is the value of delta for minimum deviation? Clear? So consider triangular prism. Let a ray of light PQ strike on the surface AB of the prism, then refracted by the face AB towards the base of the prism. And again, QR is the refracted by the face AC away from the normal. Yes. First, it is in the first situation and getting inside to the denser medium. So it will bending towards the normal, and here it is bending away from the normal and making an angle E. Now, I is the angle of incidence. R1 and R2 are the angle of refraction by the face AB and AC. Yes, write this one. R1 and R2 are the angle of refraction by the face AB and AC. A is the angle of prism and delta is the angle of deviation. Now, come to the diagram here. This one diagram, triangle Q and R. Triangle Q and R. You see the sum of all the angles here equals to 180 degree, of which angle R1 plus angle R2 plus angle Q and R equals to 180 degree. Clear, students? Number one. Yes or no? So angle R1 plus R2 plus Q and R equals to 180 degree. And now in quadrilateral AQ and R. Yes, check there. This is a quadrilateral A. This is Q. This is N. And this is R. Okay, so these both the angles are how much? 90 plus 90, 180 degree. So in the quadrilateral AQ and R, you can write angle A plus 90 plus angle N plus angle N plus angle, again it is 90 equals to 180 degree. Sorry. It is equals to 360 degree. Yes, as it is a quadrilateral, so sum of the quadrilateral A, Q, and R, okay, is equals to 360 degree. Yes, clear or not? So equals to 360 degree. So 90 and 90 become 180 and you having angle A plus angle N. The full name of N equals to angle Q and R. So more better you have to write it Q and R. So angle A plus angle Q and R equals to how much? 180 degree. This becomes equation number 2. So we have two equations. This one is equation number 1. First one, angle R plus angle R2 plus Q and R equal to 180 degree by the triangle Q and R. and this one. As these right parts are equal, so you can compare the left part or also equal. So what is left part? Angle R1 plus R2 plus angle Q and R is equals to angle A plus Q and R. So angle Q and R cancelled out, and you will have the relation R1 plus R2 equals to angle A, or you can say A equals to R1 plus R2. Got it? We compared right part and right part both 180 degree. So left part are also comparable. So A equals to R1 plus R2. Okay. Check here, this is delta, and by the exterior angle theorem, delta becomes equal to delta 1 plus delta 2. Yes, this angle is how much? This is delta 1, I1 minus R1. Do not write it delta 1. You just see here, this is total angle I. Out of this part R1 is subtracted, then the upper part will be as I1 minus R1. Similarly, this total part is E and R2 is get away. So this becomes E minus R2. Yes or no? So by the exterior angle theorem, if we have one angle as I minus R1, another one is E minus R2. So the exterior angle delta, what is exterior angle theorem? Exterior angle said that this angle is 1, this angle is 2. Then this angle equals to angle 1 plus angle 2. This is called exterior angle theorem. So here the delta becomes the sum of I minus R1 plus E minus R2. Yes or no? So delta is equals to I minus R1 plus E minus R2. So delta equals to I minus R1 plus E minus R2. Why? By exterior angle theorem. Clear? So I minus R1 plus E minus R2. So make I and E together. So it will become I plus E minus R1 plus R2. We just have figured out that R1 plus R2 equals to A. So in the place of R1 plus R2, we can put A. So it will become I plus E minus A. Okay. So I plus E equals to delta plus A. Make A this side transpose. So I plus E equals to delta plus A. Okay. Clear? Okay. For condition of minimum deviation, this is experimental conditions. We have to just learn this. So for delta equals to delta minimum, we seen I equals to A, means angle of incidence equals to angle of emergence. I equals to E and R1 equals to R2 equals to R. Both the refraction angles should be equal. Clear? So I equals to E and R1 equal to R2. Then what happened? We have R1 plus R2 equals to A. So R1 plus R2 equals to A. You have to put R plus R equals to A. So 2R becomes A and R becomes A by 2. Clear or not clear? Hmm. And I plus E equals to delta M plus A. For the minimum condition, we have the relation I plus E equals to delta plus A. So when you are talking for minimum angle, so for delta M, when you place in the place of delta, you provide delta M, then I becomes equal to E. Okay. So you can put here I plus I because I equals to E for the condition of minimum deviation. So this become delta M plus A. So it has to be 2I equals to delta M plus A. So I is equals to delta M plus A by 2. Clear or not clear? So we having the values for I and we having the values for R. R equals to A by 2 and I equals to delta M plus A by 2. So we got I as delta M plus A by 2. We got R as A by 2. Now the refractive index of prism mu by the Snell's law, it is equals to sine I upon sine R. So you place the value mu equals to sine of what we have got I as delta M plus A by 2 and we got R as sine of A by 2. Clear or not clear? So this is the derivation for the refractive index for the medium of a prism. So this is called refractive index for the medium of prism. You know, this is equals to mu 2 1 equals to sine A plus delta m by 2 upon sine A by 2. Clear? Now, one more consideration for a small prism, thin prism, for thin prism, the angles are very small. So sine theta is just considered to be near about theta. This is famous consideration in the field of optics. Sine theta is near about theta. So mu equals to what? In the place of sine delta m plus a by 2, you just put delta m plus a by 2. And sine a by 2 becomes a by 2. Now 2 and 2 get cancelled out. So mu becomes delta m plus a by 2 upon a. Mu equals to delta m plus a, delta m plus a by a. Okay. Multiply. So mu into a equals to delta m plus a. Make this side mu a minus a equals to delta m. So for thin prism, you can take a as a common. It will be here mu minus 1 equals to delta m. So this is another relation for minimum angle of deviation. Delta m equals to mu minus 1 into a. Clear? So student, we got the relation delta equals to minimum deviation. This is for delta m minimum equals to mu minus 1 into a. This is the angle through which a ray deviates on passing through a thin prism for a small refracting angle a. Yes, because we have done a consideration here. For a small angle, sine I1 become I1 and sine R1 become R1. So we have eliminated the sign. Now the yes, rest all the things we have calculated. Mu, we have the formula sine A plus delta m by 2 upon sine A by 2 completed. So this is the formula for prism. Done.